It's hard to be a gazillionaire on Etsy selling beads. You can't make a service call on a satellite.
It's kind of just the right thing to do.
The three things that sell are quality, service, and price. You need two of those three to be competitive.
Episode 2, holy moly, it's episode 2 of Making the Most of MOSA with Jim Scott. How you doing? My name is Rusty Humphreys. I don't even know why I'm here other than I know Jim. Jim is a guy I've known since the late 1900s.
Right.
About 1990-ish. And one of the smartest guys I know, one of the nicest guys I know as well. But Jim is the senior engineer and visionary at a place called Seco Seals. Seco Seals is one of the leaders of seals, and how they work, I have no idea. The only thing I do know is that they never fail, they never break down, they work 100% of the time, and they're in rockets and in satellites and submarines and in airplanes where they really make a difference. And so what Jim has done as an expert in this field is he's figured out how to standardize parts and processes in a way that makes it so that it's compliant with government rules and regulations, enabling his business to scale up and be able to work with the military and the most advanced products in the world. And by watching this show, maybe your products can get there as well. Now, Jim, this episode is called Scaling Your Business with MOSA. How do you do it? Is it easy?
No.
Okay.
It's not.
All right. Thank you very much. Good night, everybody. Okay.
No, but it's worth it.
Okay.
It's nothing. It's like, getting in shape, going to the gym. You have to have a plan and you have to work your plan.
Okay.
The plan is out there. And
great example for us two guys, getting in shape, going to the gym. Anyway, yes.
Yeah, Jim-oses.
But so it actually not only makes your business bigger, but if you have these standardized processes, from what it sounds like, you're making your business better. It's a good thing to do anyway.
Well, when you run a business, things break and there's always the unexpected, right? So what you minimize that by using as many COTS, commercial off-the-shelf products, as possible in your business.
Okay.
Then that allows you to free up your time and energy on things that you don't know. That makes you different, that makes you specialize.
Okay.
And by standardizing, it's easier to repeat. It's easy to make one pizza. You can make 10 pieces. How do you make 100,000 pizzas?
Okay.
You have to have systems in place. They have to be modular. They have to be open source because you can't have a wheat field and have cows to make cheese and to make your pizza.
Right. Okay, you were talking with Bill, our engineer. We're going to bring Bill in a little bit, too, because he actually is a guy that understands this way better than I do. But Bill was in the Navy and sailed the 7 seas. He was in the Navy. He could do his mind at ease. Oh, listen, that's a Village People song. Sorry. But Bill understands this. But the one of the things you were talking with him about was your own company, Seco Seals, and that you gave the patents to the government. But by doing so, it actually helped. I would think you'd be giving away the secret sauce and you'd go out of business because it'd be easy to steal. But that's not what you were saying to Bill, unless I misunderstood what you were saying.
So for a small business guy like myself, they teach you in the schools, you get a patent, and then you license it to some big company, right? And they pay you a fee, and that's how it works. But that didn't work for our thing because we had a proprietary product, but we decided it was better to give it away.
What, are you stupid?
Probably, but the three things that sell are quality, service, and price.
Okay.
We knew you need two of those three to be competitive. We had all three.
Okay.
We decided early on, quality, service, and price. We were going to be the best, and we are the best.
Okay.
We're 80% market share of this in the world. That's it.
Sweet.
Well, it took 54 years to get there.
Right.
But we're that. And so as long as you're those three things, we were comfortable enough because people have way more money than us. If they're going to do it, they're just going to take it from you anyway.
Okay.
And they're going to make you spend millions of dollars on legal fees and you're broke. You can't compete. So we would give it away, and we made it a national standard by making it a national standard through Society of Automotive Engineers, then it became accessible by anybody, the design, but it's a Seco seal. Our branded has tighter tolerances than the standard.
Okay.
And so then the engineer, we give away the design. We give them the CAD drawing and say, put it in your product. And then when they test it, then it goes back, they make a spec control drawing and it says, use Jim's product only.
Because it's not worth it to them to go and make that product that you make, because you make it cheaply, you make it with a great service, and not make it cheaply, but it's inexpensive. So you got a great product, you got a great service, and a great price like you were talking about. So there's no reason to go and make another one your own. You just might as well just buy it from you, right? Is that what you're saying?
Well, yes, but there's more than that.
Okay.
Because to put it on an airplane, for instance, you have to run it in a test for 500 hours, or there's a whole lot of testing. Well, like our product goes into space every day. Every satellite, most every satellite, U.S. satellite, has some of our, almost every rocket that goes up has some of our components.
How many of your seals have failed up there?
0, because you can't make a service call on a satellite yet.
That was a setup softball. I gave him that one. That's one of his catchphrases for the business. So just gave it to him. Anyway.
Oh, but
yeah,
tailing off. So Goddard Space Science, we worked on making this little R2D2 unit that goes up and refills the satellites. So let me tell you about Can I talk about this?
Please.
Yeah, Landsat 7, $500 million satellite, and it's wobbling. It's where you get all your GPS.
Ooh.
All right.
So we want this one working.
Right.
And my daughter can't get anywhere without the GPS.
And as it's coming down, and it doesn't have the stabilizing little directional things to do it, to hold it steady so it's wobbling. And eventually it's going to go in the atmosphere.
Okay.
$500 million up, down tubes. So the bright guys at Goddard Space said, hey, why don't we go and fill it up? It has a couple little tabs. We could fill it back up. So they make this R2D2 in this arm. Mm-hmm. And it goes up and it has we said, so they can go up and put oxidizer, fuel, and a pressure.
Okay.
Right? And they can refill it and it can go back up and be smooth. So there's 5,000 U.S. satellites up there. With this one machine, they can go and refill all those. They're all degrading because they've lost control. They're spinning. We could refill them. It can go back and perform. We could double the satellite, billions and billions of dollars. Right.
And they came to you because you had a standard seal to help them with what they needed in that product.
No.
Thanks for coming. Good night, everybody.
Well, no, it was better than that.
Okay.
They needed it right away.
Uh-huh.
And they needed 100% solution. And we're all over their lab anyway.
Right.
And so they came to us because we know, or I know, given a set of parameters, how to best make something that works.
Okay.
Out of the universe, because we have to buy standard products that we can actually get. We can't go mine things. We can't make it with things we can't get.
Right.
Especially in a short period of time. With technologies we haven't proven out.
Mm-hmm.
So what we know how to do, and we know how to do it really, really, really well.
Okay.
Right. And so they called us because it was us. And they said, here, Jim, and I'm not the CAD guy. I'm the napkin guy. I'm the guy who draws on, then holds it up on the Zoom meeting.
Okay.
Right. I have a guy who does SolidWorks, who's super sharp.
Right.
But, and that's how the sausage is made. That's how it works. And so, but going back to the standard, so we gave it away. And so now I have 200 spec control drawings. It's standard. Anybody could make the part. They won't make it like us.
Right.
Because we inspect every part. We have our systems. We have our quality systems, and we're licensed by a third party or certified to make aerospace. You have to have all these things that you can't get unless you're using you have to have a system to use open source. Otherwise, you have to make everything. Mm-hmm. And you can't do that as a small system. You're dependent upon your supply chains. Right. And so when you think about it, if you have enough money, this show's not for you. But if you want to grow, you have to think in these terms, especially with dealing with big companies, because they have all the money.
Right.
And the government has all the money. There are some few things that you can do, but it's hard to be a gazillionaire on Etsy selling
Right.
beads, right? But they're standardized beads, and then you grow from there. You know, everybody starts somewhere.
Right. Okay, let's talk about starting from somewhere. Bill, turn on your camera, would you? Bill is our engineer in the studio, and hopefully we'll be able to all hear him and talk to him. But Bill understands this from a different point of view because, Bill, you were in the Navy, and you saw a lot of things that weren't standardized, were not MOSA, and can see the benefit of what Jim's talking about, right?
Yeah, that's correct.
Don't be too excited about it there, Bill. If you would just calm down. We're trying to do a program here. You were telling us an example of something that you saw. Was it on a plane, in a boat? What was it that you saw, and what was the problem?
Right. So I was in the Navy for 10 years, and I was both a technician and an operator on my system. And one of the most frustrating things was, one of the things I was referencing was BNC connectors. We had a lot of different modules that were connected together to transfer a signal from one module to another. We use BNC connectors for the electronic signal. Some of the BNC connectors were a standard size. You know, you could run down to, well, at the time, Radio Shack, if anybody remembers that. Yeah. And we could pick up a BNC connector, crimp it onto the end of a cable, and we're fine. But then some of the BNC connectors, very select ones, were very small. They were just slightly smaller, and we couldn't just run down there. And there were maybe one or two manufacturers in the world that actually make them.
Were they better? Could you tell a big difference that they were something special?
Well, the only thing that I could figure is they were slightly smaller so that they fit in a smaller footprint. But I mean, the system could be designed in such a way that it would accept standard parts, in my opinion, without a problem. I'm not an electrical engineer, but working on the systems for 10 years, that's my opinion. That's my real world.
You saw that was a engineering error, or a way maybe for that company to charge more to the military because it was a certain size that you couldn't just go get at Radio Shack. Is that what your thought was?
Oh yeah, I mean the joke was it was mil spec, right? So you have to get a hammer. You have to have a mil-spec hammer. It's going to cost you $5,000 instead of running down to the Home Depot, picking one up for $10.
Mm-hmm. I mean, that's one of the reasons why, Jim, I think this is important for congressmen and for government officials. And that is, what you're talking about is not about creating things that are going to cost more. You're not talking about things that are going to be more difficult to get. You're talking about things that are going to be standardized, which will lower the cost to the military, which lowers the cost to the taxpayer. And that's why I like this, because it seems like it's kind of just the right thing to do.
It is. It is. You know, you want things to, especially with taxpayer money, which is all of our money, we pay it coming up on April 15th, that we're good stewards of that money, and we buy products, especially for the warfighter, that work and that can serve us way into the future.
Right.
But
I want those products to work not just for the taxpayer too, but for that serviceman, that serviceman or woman that's out there putting their life on the line for the country. Damn it, that stuff needs to work when it needs to work.
Not to tout Seco Seals, but think of all the airplanes that are still flying. The B-52. We're all over the B-52. F-16, F-18, M1 Abrams tanks. You know, those are things because they've been using MOSA all along. F-35 is a great plane, but they're still working out their interoperability because they got 3 levels. It's complicated. They made it overcomplicated, in my opinion. Okay. They're having issues with flyability. Hence, the F-18, you can hang any kind of ordnance off the wings. Okay. Right away. So you invent something, you hang it off there. F-35 has base, doesn't fit. You have to think about it for a while. It wasn't designed for that. They didn't have. But back to your congressman, I mean, they go when they review bills. What's the environmental impact? What's the financial impact? What's its carbon footprint? You know, my goal would be to have what did you think about MOSA? What elements when you make anything they spend any money on in any sector, what did you think about?
So that should be a question to the manufacturer. What did you think about in a MOSA standard, right?
No, you're thinking about a Medicare bill, and they're talking about hospital administration. You know, what did you think about using standard products over proprietary products, generics? Can we use generics instead of, charging $100,000 for insulin? Can we charge $35,000?
Okay.
Right? Insulin is insulin. Things are out. Let's use generics where we can, where we get the same bang for our buck. We're not about enriching, milking the taxpayer.
Okay. You just said something. Is MOSA similar to generic?
Yes.
Okay. It's the same thing. It works just as well as the name brand product, and there's no reason not to use it. Is that
Modular Open Source Approach? It's an open source. Generic, by definition, is open source.
okay?
It's out of patent. You can use it. It's modular. You can identify it in time, space. And it's an approach to implement it in your system. It's just a tool. It's just a filter that you can push it through. And the whole idea of MOSA is to use as many of those as you can. And the things that for your business or your process or your product that you can't buy it, you focus your energies and be the best on that.
Okay.
And serviceability, and try to make that as standard as possible to get it out there. Because unlike the past where you get a patent and milk it for 17 years, it's moving fast.
Right.
Technology is changing. And with the computing and everything, it's going to be moving in faster.
Right. AI.
You got to just got to get it out there and be the best, make an impact, service your customers, and establish a beachhold, metaphorically, of your product to get out there before the next guy.
Okay. What is ATR? This has got you going. He's been talking about ATR. Ask me about ATR. I don't even know what ATR is. What is ATR?
Air Transport Rack.
Woo! I'm glad I waited for that one. Woo! Okay, everybody. Buck, you should know. Why is that exciting to you?
Well, those are the racked little boxes that you might have 100 of them on an airliner.
Okay.
Right, or a military, and they put interchangeable boxes, modular boxes, and they swap them out. And it's for cooling systems for your avionics or your radios or your environmental control system, the air conditioner, or every component has its own little box.
Okay.
And they can't put an airplane on the rack. They go in there, they have diagnostics, they say, just change out that box and put that box back in.
Yeah, that makes sense.
And every so often you have to calibrate them and test them so they'll pull the box off. They don't leave them in there forever.
Right.
You don't want them to till they fail. We don't need failures on anything.
Right.
Right. So you have in your maintenance cycles, you pull modular boxes out and you go calibrate them and you put another one back in so your airline keeps flying.
Okay.
Or your airplane or your helicopter or your car or whatever you're going to be doing. So one of the things that happens, there's a thing called LFT, liquid flow through. So when they have these boxes, they use them on, when you go, most of them are air cooled, ambient air. They have a little fan like your computer.
Okay.
Your tower computer has a fan on it. Well, when you get up high at the extreme, or it's humid or something, maybe it doesn't work the same. So like your car, you have a liquid radiator.
Okay.
They got rid of the Volkswagen, most of the air-cooled engines, right? Why? Volkswagen, modular open source. You could work on it yourself, air-cooled, really simple, cheap.
Not working on a lot of Teslas anymore.
In my opinion, that's why they don't make the VW Beetle anymore, because it was open source and you could customize it, and there was no aftermarket.
Right. Okay.
We shot that one.
Right.
Okay. So liquid flow through. So why is this an issue? They have these new chips, right? The AI chips. They're going from 70 watts to 210 watts.
Okay.
Right. And when you have more watts, just like your light bulb, what happens? It generates more heat. Way more heat. When you have heat, they start to fail.
Okay.
They have the ambient air on these ATRs is not going to be enough. They're pushing towards LFTs, pushing the liquids through liquid. It's a big deal because they have to re-engineer all the boxes.
Okay.
Not the interior component. Well, they're changing the interior components. They just can't slide a generic circuit board because they're getting smarter way faster.
Okay.
And more heat. And to accommodate that and have them work 100% of the time. without fail.
Right.
You need to enhance the cooling system. We personally have experience on like the radar array for the Patriot missiles. Same thing. It overheats. The heads-up display on a fighter overheats because they didn't engineer the sun bouncing off the interior of the windshield. Right?
Okay.
And so it fails. You know, we worked on a ATR Pratt & Whitney engine where it shouldn't have failed, but at high temperatures, it melted some O-rings.
Whoops.
2 airplanes crashed.
Oh, wow. Okay.
Bad.
Yeah.
Very bad. So we made them a metal seal to replace O-rings. Ingersoll Rand. We have different things where things should work. They engineer in the lab. They work on your laptop.
Right.
And they're supposed to work, but the world isn't fair and it's not consistent and there's things that are outside. So we have to be aware of that. So, but the ATRs, so think of all the things. You're building a computer product. These new chips, you're going to have to think about heat. So you're going to have to think about modular cooling systems, because if you're going to make a new computer, you're going to have to think about cooling it. The supercomputers, it's all about heat. There's other things besides input and output.
Okay, so are you saying that there's these new chips that are going into the ATRs are kind of spreading across the world? Everything. Okay,
they're going to be everywhere. They're going to use the new NVIDIA chips. These new G-Whiz chips are going to be. They're super, super expensive now, like $10,000 chips.
But they're going to come down.
Well, they should.
Yeah.
They should. That's the way it historically goes. But the new chips right now are going to be generating more heat. So now we have a heat problem.
Okay.
It's not a problem. It's a challenge.
Okay.
And so we're going to have to we're personally looking into being a standardized solution, because we know how to seal whatever they're trying to do.
Right.
Because we've done it at the highest level. And we're bringing that into commercial. So for those people that are dealing at the highest level, we try to make it for the masses, or not masses, but for commercial applications. Those things we don't have to worry about. And I don't want to read about my company on CNN.
Right.
That's something.
Because what you're trying to do is standardize those seals that would work in that process, but also in an air conditioner or in a cooler at Walmart. I mean, that's your idea, is to make sure that all those things are standardized, that could fit and work wherever.
Oh, well, now you got me going.
Yeah.
So HVAC uses Freon. Freon, it really does get rid of the ozone layer. They're trying to phase it out, but they're reluctant.
I say, give me Freon or give me death. Give me Freon or give me death.
Right. No ozone, you're going to get skin cancer.
Yeah.
You'll be wearing a hat and long sleeves. Almost all in commercial HVAC, heating, ventilating, air conditioners worldwide, they use a 45-degree flare. These connections leak, right? And you leak out the Freon,
And that costs money, and it's dangerous.
And it's a major pain, especially if you lose it on a big building with one big cooling system. Well, I patented a seal that goes in there when you put it in there, because right now there's a fitting and a tube, and you open and close it, and then it doesn't seal the same.
Okay.
So I designed a seal that goes in there, you torque it up, never fails, never leaks. So you could plumb 10,000 connections on a building and have 0 leaks until you open and close it again.
Right. That's amazing.
It's not there now. How can it not be there now?
How could it not be there now? What's the problem?
My friend is a maintenance guy for an apartment complex. He has 5, they have a common HVAC system. It's built in 1971, train system. It's perfectly fine.
Okay.
One of them fails. They said, we don't support it anymore. And he goes, but you'll have to buy a new one. They're $250,000 each.
Wow.
He goes, I don't have the property owner doesn't want to spend that. These are fine. They work fine. I have them work tuning like a fine Swiss watch. So he goes in, he cuts the pipe, puts in a seal, check, doesn't leak.
So it works fine now.
It cost him $1, but he got to save the other $249,999.
Okay, so the whole idea of scaling your business with MOSA is what?
Standardize to scale. Use as many commercial off-the-shelf products and processes as you can. Write it down. put it on a piece of paper for reference so you can repeat it over and over and over. You can't go to 10 to 10,000 unless you write it down and use as much standardized stuff. And then anybody who does any kind of volume on product or process, you have to write it down and do it the same.
Okay. And then having that, is that how you can then approach the government? That's, I guess, another show coming up, but that's kind of how you get started so that you can then scale using the government using MOSA.
Right, because dealing with the government, you not only have to do that, but you have to tell them you have to file your tax returns and be a good guy, and you have all these terms and conditions of things that you're not going to discriminate, and you're fair, and you're not taking bribes and all these kind of things. Okay. All these legally things, but and as long as you're a good person, and you do all the things you're supposed to do, then you can deal with them. And then they give you what's called a CAGE code, commercial and government entity, and that gives you that you're in their system.
Okay.
If you get in that system, you do what you need to do to get the CAGE code. You can go to SAMS.gov, and there's a system for award management, and then the government can give you money. That'd be cool, right?
Right.
Because they're 30, 40% of the economy, and they buy all kinds of stuff, And if you deal with any company, big company that deals with the federal government, they have flow downs, and they can only use these people for major contracts. If you don't do this, that's how you get in the river. Otherwise, you're in the trickling stream of money. Right, which forces you to set up your billing systems and your accounting and everything you're supposed to do to be a big business.
So it's kind of one of the things that entrepreneurs aren't great at, following those systems and doing those little things. Entrepreneurs are usually big idea guys that want to get it done. So sometimes what you're probably saying is to get into MOSA is you need to standardize what it is you're doing, kind of break it down so you know exactly what you're doing, and make it sure that there's nothing wrong going on there, standardize that process, and then you can upscale your business.
Well, every entrepreneur and every small business needs a charismatic leader that has the vision and the idea.
Right.
And that person starts doing everything, but you soon find out that you don't know as much as you thought you knew.
Right.
But you can do, and you can find people that are really good to be on your team. You're the quarterback, but you need blockers, and you need people to catch the ball. You need accountants. You need organized. I surround myself with organized people. With smart.
Now, what am I doing here? Oh.
Well,
but the organized people are very important. They're not going to be the big idea guy usually, but they're the guys that make sure the big idea guy does it right.
Right, and then they watch out for you. They guard your back. I have an accountant. I have an IT guy. I have dedicated staff that's worked for 20 years that know the processes, and they have MOSA think, they have Seco think, they have the process, they know what it does to do it right every time. And so they can pick up the phone and answer any questions, because like my company, this doesn't have to be your company. I have a linear org chart, with my 15 people, and so anybody can talk to me, right? You too much, you lose stuff where you have to go up a chain of command, right? And you lose the immediacy, and you don't delegate. If you trust your people and let them worry, they worry way more than I worry.
Well, I worry that the show is getting a little bit long, so we're going to wrap things up. You're going to learn more about how to scale your business with MOSA using the, what's it called? What is it? Modular
Open source
approach. Okay, the modular open source approach. We're going to try to help you get there with your business and teach you more about how to do that in the right ways, and try to make this more interesting and exciting. We're going to get Bill, the engineer, coming up a little bit too, from the Navy point of view. Until then, my name is Rusty Humphreys. I'm just here hanging out with my good friend, the host of Making the Most Out of MOSA. His name is Jim Scott.
To be a whale, you have to scale.